So we're almost on a semester, right? So we've got, including today, there's 3 classes left. So on Thursday, I have someone coming in from outside. Uh, his primary purpose is to hire people. So if you're looking for a job, um, you definitely want to be here on Thursday, and you probably want to bring just a resume just in case, right? I mean, it's like, oh, I just happen to have my resume in my, um, right. He's a former San Diego State student. He did a thesis under me, and he went off and worked at Qualcomm for a while. And then he had this, he got tired of Qualcomm, and he was in a special group where they explored new areas. He got this, oh, this is a great idea. And the Qualcomm goes, not for us. And so he and some other people formed their own company called House Call Pro. Um, and it's one of these niche places where, well, we've got this saying in computing that the future is not uniformly distributed. In some places it's already here, and some places it's not. And so people like electricians and plumbers, I mean, they're so busy, dealing electrician stuff and plumber stuff that they really haven't caught up with the 20. And their problem is they're usually just independent people, and you have to worry about scheduling things and taking phone calls and all this stuff. And it's like, so what they do is they produce software that, from the phone, they can manage they can schedule things and do billing and all this sort of stuff. And, so all these sort of people that come and fix things in your house, so it's plumbers, electricians, and maids, and, laundry, all this sort of stuff, that they're really not technical people. They're not going to have their own websites. They're not going to do all this stuff. And it turns out that, it's actually a big business. Um, and so this company has probably been around for like 5 years. So it's still a startup, but he contacted me this summer and said, well, we need to hire like 40 people by January. And like, that's a lot of people for a small company like that. So he'll be here, and he's actually very good at mentoring people. I think he'd be interested in both. So if you're looking for an internship, or the company is in San Diego, yeah, yeah. And so he'll talk for all. I mean, he'll talk about, how do you get jobs, what you should be doing to improve yourself. And I'm hoping that I'll have exams done by Thursday. So after he's done, I can pass exams back. Um,
Do you know the experience he's going to be looking for, or is it just like?
Yeah, I don't know off the top of my head. I know they do back end stuff. They also have a website they needed to deal with. They also have apps on Android and iOS. Um, and so then next week, a week from today, is our last class. And so they'll do sort of review, get ready for the exam. And as someone pointed out, I posted the wrong exam time on the wiki. It's 18th. I just let's see. Last week, Amazon had their conference, reInvent, right? So, but this week, Google has a conference. Um, it's their Flutter conference. And so they announced today that Flutter is now out of beta. Um, and if you don't know, Flutter allows you to do Android and iOS apps using the same code base. And they also have a beta version to also produce desktop applications. And they also announced, I think it was called Butterfly, a system to take the same thing and put it on the web. So they're really trying to build this up. They want to attract programmers to use the system. Why? Well, because they're creating another operating system, right, called Fuchsia, um, which sounds like they will want to replace Chrome and Android. But to replace Android, you need lots and lots of apps on day one, right? And so the game plan is provide a development tool which is good enough for people who can do Android and iOS apps now. So in 4 or 5 years, when they want to produce Fuchsia, they're like, oh, all those apps you've been doing for the last 4 or 5 years, they automatically run on Fuchsia, right? So that they can. This is Google.
Manages Fuchsia's
That's a good question. I don't know the answer to. Um, they're writing the operating system from scratch. So Android is built on top of Linux.
oh, it's gonna be a
Whole new kernel. It's based on, I think it's called Micron or something. Um, but they're definitely having trouble trying to unify Chrome OS and Android. It's not working. Um, the reviews of their Android apps running on Chrome OS are like, this is really buggy and not very usable. Um, yeah, but Apple targeted iOS towards phones and Mac OSs, and here they got Android for phones and Chrome is for like Chromebooks, right? Um, and so this is basically an operating system they can run Chrome on. So it doesn't have all the services you expect even on a phone, and yeah, so probably also they're probably just like, well, they got a bunch of smart people, and you have to keep them busy. I mean, keep them, like doing some interesting stuff, right? So yeah, so maybe in 3 years decide we don't need right Fuchsia, and we'll just dump it. But
I think they said that, right? They said the number complaint they feel like they're realized. Like, oh, I'm bugging.
yeah, yeah, I mean, at the end of the day, most work is sort of routine, right? I mean, and if you want to run a big company like that, you have to maintain all those servers, and someone has to test it, someone has to maintain it. Their whole ad platform, someone else make sure it works, right? And add new features. And
Here's feeling.
okay, so that's sort of the game plan. Here is, yeah, but it's out of date, right? 2000, so it's 18 years out of date.
That's
Um, yeah, it's just basically a list of patterns, right? Um, but also, I think that the pattern movement has peaked a number of years ago. Um, it was a genius idea in the sense of who's going to go look for ideas in industry that work well? Usually people in industry are too busy to do that. And people in academics, they have to write papers so they can, go off a review board and say, I've done something interesting. But how do you make, well, here's something that people have been doing for, years now and works, and I published a paper about that. How do you make that sound new and exciting to the people who review the academics? Well, it's a pattern, right? So for me, that was the genius of it was like, all of a sudden academics could publish papers in respected journals and conferences by saying, look, here is something people in the industry have been doing for a long time, and it works, and here's this general structure. And if academics don't do it, who is going to do it, right? And hence you get, a book of just listing a bunch of patterns that people have written about. And of course, how long can you do that? Well, eventually, you discover 90% of what good ideas, right? And after that, it gets hard, and academics move on to the next new biggest thing, right? So one of the topics I want to talk about, we started last time, is basically how do you do business? How do you do business rules, right? How do you make the software flexible enough so that we can add business rules as data? And so there were a couple of papers published a number of years ago on metadata and active object models, and another one on frameworks and so metaprogramming is just writing code that writes code, right? In the Java world, that's sort of hard to do. Lisp is sort of famous for this. Why? Because a Lisp program is just a Lisp data structure. Literally, that's all it is, right? Is a common structure in Lisp is a list, and a Lisp program is just a list. That's it. So there's no, what's that? A lot of parentheses, but, right. Yeah, it's also a language that I don't think should be taught in a programming languages course because you only spend a few weeks on it, and in a few weeks in Lisp, you just learn to hate it because all the parentheses, and it's a completely different way of thinking, and you're trying to write Lisp like it's Java, and you just doesn't work very well, and so you're just frustrated, and then after 2 or 3 weeks, you go on to some other language, right? And then you come out and saying Lisp is terrible. Why would everyone want to use Lisp? Yeah, there's a big learning curve. The syntax is easy. Begin, paren, end, paren, right? But actually, and how to actually utilize that takes a fair amount of time because you want to write it like Java, right? And it just doesn't work, right? Lisp is a terrible language to write Java programs in. It just doesn't work. But it does make it easy to do metaprogramming, right? And so, yeah, things get several forces. One is as software evolves, you want to make it more and more general, right? You want to add this case and that case and this case, and so it gets bigger and bigger and more general. And um, so you end up trying to make it more flexible, more general, which makes it, well, harder, right? How do we do this? Um, so one property uses the property pattern, and for the Python people, this is going to be like, huh? Um, it is a property, right? Um, and so you want to add properties to existing class. We want to do it dynamically. Um, and Python is like, you just do it, right? I mean, you just, a dot foo equals 5, and if foo's not there, it is now, right? Um, wherever in language like Java or C++ or C Sharp, you can't do that. So what do? Well, you do what Python does underneath the hood, right? Is you basically have a hash table, and right, um, so you want some mechanism to add and delete properties at runtime, and so what's a property? Is this a key? I mean, what's in Java? What's a field? It's just a key value pair, right? That's it. Um, in any language, a data member or field is just a key value pair, right? Foo.a, and we get the value, or foo.a equals 6, right? Whether it's in Python or in Java. The difference in Java, is hard coded into the class, and so presumably it makes it more efficient than Python. And Python is just a class in Python is just a hash table, right? Um, that's why you can do it. You can add properties dynamically. Um, and so, yeah, so you want to key in a value and maybe some descriptor to tell you what it's about. Because if you add, the problem is if you add it dynamically, what is it, right? And the problem is if you add it accidentally, that's when the fun begins. But so again, just add a hash table, right? And add properties and get properties, and then, yeah, there's all kinds of things. Add a property, delete a property, get the property, add a descriptor, right? I mean, and there is, a properties class in Java, right, already. So you can just basically incorporate that into a class. And now dynamically we can add properties, but that doesn't answer the hard question. How do we use it, right? Yeah, here, but the strings are the keys. I think properties can use any serializable values for objects, if I remember correctly, but we can always create our own hash table, right? That's all. A property is just a wrapper around a hash table. Um, but it makes things more dynamic in the sense of, an individual object can have different fields or properties in other instances of that class, right? Um, and so we can add fields, individual instances, add them, remove them at runtime as we need them. Um, and if we add descriptions, we can then, built in things that help our tools see what's going on. The Python people should be yelling, yeah, 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 right? They do this all the time, right? Um, but you lose that compile time support, right? What's there? We don't know. Um, now we have to do this get and set thing from our dictionary. Um, In general, tools don't support it. When you go into Java debugger, you're not, usually you can see the class and all its fields, and then you can have this dictionary thing, and then viewing that becomes harder because it's a hash table, and it's more expensive, right? Presumably, a field access in Java is a lot faster than accessing a element of a hash table. Now I want to change gears a little bit and talk about this other paper, the user-defined product framework. And we'll see if the property comes in. And the goal here is, this framework was, we want to allow users, right, to construct this business object from existing things without having to be a programmer. And so the case example was ITT Hartford is a big, huge insurance company. I don't know if they're in existence anymore or been bought out by, there's been several major turnovers in the financial world. But the problem is, how do you represent all the various types of policies and variations in policies that they will sell and their software, so that agents can then somehow, do this, and here's your print, and here's your policy, and keep track of it in the back end too. Right, and so there's always various policies, different types of policies for different things, and so the claim is, if you want to do a strict class hierarchy, it just gets too big. There's too many variations, different types, and then you want to combine them because you often, sometimes you just sell car insurance. You may sell car insurance with homeowner insurance, and right. And so one solution, they say, well, we can use composition, right? So maybe your policy has this composite object, so now we can put in any type we want there, right? So now we just, create the subclasses for there, and then your policy, we can stick in ones we need, right? And we see that, right? And it works, right? And the problems are, of course, you still have a large number of component classes you need, and if you want to add a feature, you have to add a new class, right? And that's a sticking point, because now that means you have to go back to the programmer, and the programmer has to, type away and compile and add the system. And so what solution can we use to having to avoid the subclass component? Oh, we make properties, right? So in each component, there's going to have a property, and the properties have a name, right, and a value and a type. And so what type of policy is it? Oh, it goes in the property, right? And so now for each component, we can start adding these properties at runtime instead of at compile time, right? But now the problem is, right, for these subclasses, we still may need different behavior, right? And how do we add behavior? Oh, once we go back to the programmer, right, and now we have to recompile, and it's not what we want. Well, we've seen the strategy pattern, right? So we could have different strategies. For different types of, but the problem with that is now we need to have the strategy classes, right? So we're back to the programmer subclassing strategy. Interpreter pattern, right? So now we can create a little language, right? So we can create a little language so that at runtime we can actually take an expression, right, and evaluate it and add that as the strategy instead. But then we have, the various types of elements in the language. And then they have a lookup table so you can find, what each thing's supposed to do. And then you can have these rules, and you have things you do before you apply the rules, and things you do after the rules, right? Right, so now, right, so we get rid of all those subclasses by attributes to represent the thing, and then rules that give us a behavior. And then each component, we give it a set of rules. Here's how you deal with this policy, that policy. And then we can also modify them with pre-rules and post-rules to give variations. Right? So all of a sudden, right, all those patterns you've learned, it does become hard to understand, right? Because now all of a sudden, you don't have this class hierarchy where you can say, oh, this is a homeowner's policy, this is an auto policy. It's just a class that has no real context, right? It just has rules and it has attributes, and those are filled in at runtime, which makes things a lot harder to understand. But it's more flexible, right? It's more flexible. And then they want to get rid of duplication because now we're basically populating each one at runtime, right? It's even going to be harder to find a duplication because it's like, okay, we're adding this rule to this component, this rule to that component, right? And we do component, and then it's all done at runtime rather than compile time. So the type object, what's the type object pattern? Well, normal programming, the type is just the class, right? And so we have this class structure, and so there's a class for this and a class for that, and that defines what a type is. Since we got rid of all that and we're using attributes and rules, we've lost it. So how do we add it in? Well, you create an object that says your type is X, right? That's all it does. It's basically a label. And maybe some rules about what that type can do or not do, right? So now things are really getting dynamic, right? Because now the type object is like, instead of having a class called foo, we're going to have a class that says, oh, type foo, right? They can do this, they can do that, but it's that class doesn't. It's just called type object. It's not a foo class, right? It just basically a string or a field or some representation that tells you what that class is. And you can pass it around and you can change its type, right? Because it's really just an object with the type is a field inside. So all of a sudden, right, we've really, gone from a classic, creative class structure, and each class does blah, 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 and we're just basically ripped it completely to pieces, right? And we've created a structure where we have sort of a few generic classes, and we have a bunch of rules, which will assemble into, you know, another object which has a list of rules and a list of attributes. And now we can then add, and now we're going to call you a homeowner's policy. Yes. Now, for one thing that's happening, at least in my view, is once we do this, um, it becomes a lot easier to start thinking of this also as functional programming, right? Because what are your classes holding? You're holding data, right? Um, and the operations we have in those classes are just there to actually execute the real operations, which are in the rules. Which means a lot of what we're holding is just data structures, and the real operations are in the rules, which are basically a language which we have this whole mechanism to execute those rules, right? Um, and then, okay, well, I mean, if the attributes are representing different types of policies, right, then there might be special rules that only apply to certain policies, or you can't do this on this type of policy, and you can do it here, but not there, right? And so then we need to have, right, rules specific to, um, and so we can add decorator to an attribute to add, right, so it's just an example of, how they built the system, right, at this company to make it far more flexible, and how they use a lot of the patterns we've dealt with, and some other ones we really haven't talked much about to get the flexibility they really needed, right? And it's something that if you come from the Java world, you never think of, right? You never think of the solution. Never in a million years you'd be creating class structures. And Python people, maybe, right? Um, List people, oh, sure, no problem. We'll just Um, yeah,
So the solution was pattern.
yeah, yeah.
Another strategy you had to add it.
But yeah, that's basically what they did, right? So their final solution, right, is like this, right? Where you don't see, I mean, you don't see a policy, right? There's no homeowner policy, or it's just a mechanism to create rules which can then operate on attributes, which can be policies, right? And so it's really a structure that we can then use to operate on data, right? Like I said, I mean, the Java programmer wouldn't think of this solution in a million years, right? It's like you never get there from. And it's one reason why um, when you're going to school, it's good to learn not just a bunch of languages similar. I mean, if you learn C++ and Java and C Sharp, it's like that's a pretty narrow focus, right? Um, it's better to learn languages that are completely different, right? So you have a better understanding what types of things are available you can do. Of course, on the other hand, you don't know what fun is until you write a program that's going to read data and generate code to build the actual program, and you have a bug in that program that reads the data that generates the program, because now you test this program and it's like it's all messed up. But once it works right, it's like, oh, all of a sudden I just saved myself tons of time. A few more patterns. The smart variable um, pattern. This is something I've come up against many times. Doing a simulation, um, there are times I'm like, oh, I really want to know how this thing changes over time, right? Let's let's do the simulation, and then I want to plot, right, the value of this variable. And what do you have to do? Oh, you have to go into your program, and every time you change that value, then you have to write it out someplace, right? Um, Having a smart variable, it's like, oh, that'd be great. What's a smart variable? Then you can actually know when it changes, right? Without having to do anything. And like I said, in simulations, I come across it would be really nice to you just build your code, make it work, and then you can go and say, oh, I want this to be smart, this to be smart, this to be smart, and then you get the output you want, rather than have to go in and then modify your code. Um, and the same thing with debuggers, right? It's just you just want to be able to run it and then show me this, track this variable, and when it changes, stop, right? Or the third time it changes, stop so I can see what happened. Um, and then, yeah, I mean, now you want to track things in real time. You just want to tell me, okay, I need to know, when this happens so I can figure out when to buy or sell stock, or when we need to figure out order new things. Um, and also, there's a bunch of things that you may want to do when the state changes. Um, I mean, you may want to save things, you may want to cache values. Um, and we saw in your last assignment where something changes, we then want to do a broadcast. Um, and so Smart Variable does that for you, right? It's like, okay, you just set this value and you can then add code. You tell, oh, when the value changes, do this, right? And a number of languages sort of build this in now. So in Swift, um, they don't call them fields, they call them properties. And then there is for each property, you can specify what they call property observers. And so you can have a will set and a did set. So automatically when you assign a value to the property directly, first the will set will be called if it exists, and you can then do whatever you want, including canceling the change of the value. And then did set, the same thing. If it exists, it'll be called after the value is set, and then you can record the value or print it out or whatever you want, or including saying, sorry, but that's an invalid value, so go back to the old value, right? So here's an example where I create, positive temperature object, and I set it to 10, and then it prints out changing the temperature, and then I can look at the value, and it's indeed 10, like you expect it to be, and then set to minus 20, and then, yeah, you get print out change of temperature, but then when you print it out, it's still 10 because, right? Another example where I've seen this used is in the React world. So the basic idea in the React world, or what people call the Elm architecture, is you got your data, and then when your data changes, you then update the view. Usually what you do, you have your virtual DOM, and so every time the data changes, you recreate the virtual DOM, and then you display it. And so it's nice then to basically have a smart variable to hold your data, because you can then automatically trigger the updates when you just change the value without having to say, oh, wait, now I change the value, now I'll go update, right? It's like, no. The smart variable knows as soon as you change it, call it update on everyone that uses it. Right, so it's a very simple idea, but it can be very useful. Yeah, it's definitely like the observer pattern, right? But it's sort of the observer pattern is small, right? It's not like I got this big object with a bunch of fields and when it changes, I'm going to update. It's like, no, each little field, right, can be observed. Schema, um, I mean, the database world, we know this, right? How do you create a database, right? Well, each table has a schema, and then that tells us the structure. And so there, we're used to the idea of having schemas around, right? But we can do that for our code too. Now, one recent example I know of, enclosure, it's a dynamically typed language, which means arguments have no types. But that sometimes causes problems. So in version 1.9 of Clojure, they added schemas where you can declare different data types and the structures you have. And then you can actually run a special test to say, okay, do all my fields and all my arguments have the right type, right? Allows you to find, different data types. I also use a system in building web pages where you define a schema of what data type you expect to be sent from the web page to your calls, so that you don't have to do the hand checking. Oh, I expected these 3 arguments, and first one should be integer. So no, here's a schema, and you specify incoming value of this schema, and then it checks for you. And yeah, basically you have some sort of schema to actually deal with this. Describes what's allowed. Various places where we use this. I think the most recent one was GraphQL. How many people know about GraphQL? No. Not really. So GraphQL is trying to replace the REST API. And the problem with the REST API is, well, usually it's pretty common on the web where you build a server and you say, specify, here's all the calls you make on the server. Here's what this one returns, what this returns, and returns. So you have to sort of guess as to what order and what type of things people want from the API in advance. And then usually you don't get it quite right. And so then it's like, oh, okay, I make this request and I get a list back, but I didn't want everything on the list. I only want a few things on the list. But there's no way to get those few things instead of everything. And so GraphQL, what you do is you define a schema for your data types that you support. And then on a client side, your query is based upon the schema. And so you can, instead of asking for this and then this and then this, you make one query, say, give me these 3 things. Or give me this list, but only things that satisfy this condition on that list. So it's gotten quite popular in the web world to use instead of creating REST APIs. It becomes a little more flexible in what you can actually request on the client side. And it's a little more complicated on the server side, because you have to then get the request and then parse it and figure out how to satisfy it. But our last pattern for the semester, the active object model, where you actually give metadata in the object, which tells you about the object, what you can do on it. Again, when you're coming from the Java world, this is like an alien object that comes from outer space in the movies, right? Um, basically you're giving information about the object so you can do metaprogramming with that object. Um, it's something you don't use very often, but when you do use it, it comes in handy. So the goal here is just to sort of give you some, like, oh, you know, just using strict classes may not be enough and give you a flavor of some of the things people do when they A, get creative, and B, when they need that flexibility. And anytime you deal with metaprogramming, um, it, it can be difficult to develop. It's hard to understand because you're writing code that manipulates code, right? And so then and you run that manipulated code, and it's like, it's hard enough to just write code that does stuff and then debug it, right? But to actually do something, write code that writes code, and then debug that. Yeah, you make a little change here, and things go crazy over here. Um, but there are times when it actually is the right thing to do. Not very often, but like I said, that's this is sort of broaden your horizons a little peak. Um, so yeah, so a lot of when I started my degree is in mathematics, right? And so I started teaching computer science. Is like, how do you write programs well, right? It's like that wasn't my training. And I actually started teaching at UC Irvine, and there they had people they were experts, right, on large systems. And one of the faculty there actually went on to other places and got awards for all their, research into large systems and fault tolerance. And like, he's asking like, well, how do you do this? And like, we don't know. Like, what do you mean you don't know? You got the PhD in computer science. That's your specialty. And like, yeah, we don't know. Like, huh? Um, I mean, really, and actually, there's big arguments about students' programs and should you make them use debuggers. And I'm going, the debuggers you're using are terrible. I don't like them. I mean, they're a pain in the butt. But I was too new and I was too insecure to say, look, this is stupid. I mean, of course you're not going to use those debuggers because they're terrible. Um, but I also hadn't used a good debugger at that point, so I was like, I kept my mouth shut. Um, so Joel Spolsky, years ago, he used to have a blog and write about software development. Um, he also has a company, and after a few years, the company took precedence over giving free advice. Um, but he has these 12 steps to better code, um, right? Why do these make better code? Well, source controllers keep track of things, right? Otherwise, you lose things. If you can't build in one step, oh, it's a nightmare. And so then you postpone builds until a month later or 2 months later. And then it takes 3 weeks to actually build your product and to get all the bugs out that you didn't have because you couldn't build it. Um, and yeah, you want daily builds. Okay, everything's still working, right? I can still, it compiles, right? Well, that's true, but it's a first step in testing, right? If it doesn't compile, forget it, right? And that's what happens when you don't do daily builds and you wait for a week or two, a month or two to try and compile everything. Then it's like it doesn't compile. Why? But yeah, I mean, you keep track of your bugs, and I mean, um, right? Now notice what it doesn't say, right? It doesn't say anything about taking classes or it's just very simple, concrete steps that we typically don't do in schools, right? Yeah. Um, a bug database is, someone reports a bug and you need to keep track of it. If you don't keep track of it, someone's going to forget about it, right? And so you have a database of all your bugs. It could be, yeah. I mean, that's a common thing is you have tickets, right? Um, and so you want to know a description of the bug. Like I said, ideally it's like here's the smallest way to get that bug to exhibit itself, right? And then usually, yeah, and then at some point, some people will sort of classify it as hard or easy, right? Or critical, not critical type of things. And then eventually it's like, oh, it's his job and it's his ticket. It's his job to fix it. Because otherwise, I mean, what's that? So you keep track of all the bugs and keep track of where they're happening, what's going on. Um, do you have a specification of what you're trying to do? Um, he's not an advocate of agile programming at all. Um, so for a while there was a movement towards the open office, um, where okay, we want programmer interaction, and so there's one big room and there's programmers, right? Yeah, and there was actually a study on open offices, and they found out that having the open office, there was far less human to human interaction in open office and more interaction via email than if they had private offices. There's no privacy, but also like if everyone's in the same room and you two are going to talk about a problem, you're going to piss everyone. So even though you're sitting right next to each other, you're going to be like, you know, yeah. Um, Which IDE do I use? It depends upon, there's Xcode, IntelliJ. Uh, Usually I just use a simple text editor and then put it in a regular Word document and convert it to. It depends on, I mean, Closure I use IntelliJ. For Android I use Android Studio. For iOS I have to use Xcode. Smalltalk has its own editors. Um, Python, there's PyCharm. There's also now Visual Code Studio. Um, I also have BBEdit. But I mean, you have the best tools. I mean, there the point is you're paying programmers a lot of money, right? And do you really want them? Yeah. And they do some testing, but this one is sort of, at least for me, controversial. I mean, I've heard from people doing interviews, and they come across people that don't seem to be able to program at all, and they've got years of experience, and they go, "What?" But I have no idea how you actually interview people effectively because
Like, oh, we got him. Extremely nuanced problem.
right, yeah, and they can't do it. Right. Yeah, and it's like that's not a good sign. Right. Yeah, can they solve a problem and can they think through it and or Google where they do something far more complicated. Um, I mean, you just go out and say, "Oh," you grab another programmer and say, "Try it out. Try, does it work?" Yeah, right. Right. I mean, just grab the next person and have them do it. Right. Yeah. Usually the first couple of people that you have test your code, you get most of the bugs right, and after that, you gain less and less. There's less. Um, yeah. So this is, his attempt to sort of, tell people like this is what you should be doing, right? Um, Resume is just a list of things you say you've done or can do, right? Um, but it's hard to, are you a good programmer or not? A portfolio, you know, it's something that, the art people are familiar with, right? When you're an artist, you show up with, here is a portfolio of a sample of my work, right? So you can see what you do. It's a little bit harder for us. We can't carry around source code like, but yeah, but there are other things we can do, right? So like you do a blog, you do projects, put them on GitHub, right? So then you can say, here, go look at my projects I've done. Working on, various things we can do to help build up a portfolio that we can then point to. Um, Often you just want to sit in your office and, write code, but you have to communicate to people. You have to talk to them, right? You know, and, small. You may have to talk to customers of a small company, even a large company, on a team, right? And you're like, oh, we're doing this, and you think the best way to do it is that way. Or somebody think, no, I should do it this way. If you can't communicate your ideas and argue about them, right, you're not going to follow your advice. As technical people would think, oh, that it should be obvious that my ideas are technically superior to your ideas, but that's not the case, right? And you have to be able to communicate those. Um, and there, in the past, when I've gone to conferences and met the people in the industry, I always say, what should we be doing? And the first thing I always say is, you know, communication, right? People need to be able to communicate better their ideas. Linux, right, is like, oh man, there's this small little thing you can pose them together, right? Um, it says, yeah, you should be able to, deal with the file system, deal with pipes, right? Put together things to get a pipe. Well, okay, Harry, you'll be happy with this, right? Right. Um, so various things they want, right? You should be able to do these things. You expect the computer science people to do this, right? Um, just a bunch of stuff that should be easily done, right? Of course, the device is a little bit old. MP3s. But right. Just can you do these sort of things, right? Yeah. Well, I know an example. We're on a team. They didn't like someone, and so what they did is they remotely programmed his software to every time he typed a special key, a certain key, his computer would beep or.
They like the new system orders?
No, no, it was all his own software. These guys are really good. They were like, and
Was it always the same?
I, they did these weird things, and eventually the guy would call tech support, and they'd call away his computer and bring him another one, and they did the same thing. Right, but these are common things you expect someone to do. Um, right? Can you read the log file and grab the type of information? Can you use some basic, system in? Can you install Linux? Can you configure it?
Yes. Like, is it realistic to get hired in where the
Yeah.
but system administration, they're both computer related. Yeah.
So it's not like, oh, we're going to hire you to be a Linux administrator because you can navigate the file system, but it's when you're programming, yeah, you have to know how things are working, right? You have to do these things. Right. This is general information that you'd expect, savvy people to know. And you're not going to get a lot of this in classes unless you take an OS course, right? But it's, um,
Working. It's content. And that I'm really motivated. Yeah.
yeah, yeah.
When you have system administrator, system administration, like a problem, they'll each blame each other because no one knows how the other one works.
Yeah. So a lot of these things are not really things you're going to learn in classes, right? You learn by doing, and so it's not good enough to assume that just going to class and learning that material is going to good enough for your career. Right. Right. Right, but that's and having that experience and broad knowledge of how things work helps you.
Patience.
Yeah.
At least